In this video, I'll recognize how to apply state transition testing to derive appropriate test cases from requirements. In software testing, state transition testing is a valuable black box technique that evaluates how a system responds to various inputs, particularly those that change the system's state. This technique involves testing how different inputs can transition the system from one state to another. For instance, entering a password correctly moves a system from a locked to an unlocked state. State transition testing is most effective when the system has a finite number of states and defined inputs. This allows testers to map out all possible state changes and test them thoroughly. Unlike some testing methods that focus on individual inputs, state transition testing examines sequences of events. For example, in an ATM system, it tests the process from inserting a card to entering a PIN and withdrawing cash. This technique is important when a system's behavior is influenced by its history of states. For example, a user login system might lock a user out after several failed attempts, requiring the testing of the entire sequence to ensure proper functionality. State transition testing ensures comprehensive evaluation of how a system handles different states and transitions. All states coverage requires testing all possible states that the system can enter. It ensures that every state in the system is reachable and functions correctly. For example, in a user authentication system, this would include states such as logged out, logged in, and locked out. Valid transitions coverage focuses on testing all valid state transitions that the system can undergo. It ensures that the system correctly transitions from one state to another based on valid input conditions. For instance, testing a vending machine would involve verifying transitions like selecting an item, processing payment, and dispensing the item. All transitions coverage ensures that every possible transition, both valid and invalid, is tested. For example, in an online shopping system, this would involve transitions such as adding items to the cart, proceeding to checkout, and attempting to check out without an account. State transition testing involves modeling the behavior of a system as it transitions between different states based on various inputs. States are the different conditions or statuses that the system can be in at any given time. For example, it could be logged out, logged in, and locked out. Transitions are the movements or changes from one state to another, triggered by specific events or conditions. Events are the inputs or actions that cause a transition between states, and these can include user actions or system triggers. Actions are then the operations or responses that occur as a result of the state transition, and these can include processes like displaying a message, updating user data, or triggering an alert. State transition testing can be effectively represented using diagrams and tables to visualize how a system moves between states based on different inputs. A state transition diagram is a graphical representation of the states and transitions within a system. States are represented as nodes, and transitions are shown as directed edges between these nodes. Each edge is labeled with the event that triggers the transition. A state transition table is a tabular representation that outlines the current state, the event that triggers the transition, the resulting state, and then the action that occurs during the transition. For example, in a traffic light system, the table might list the current state as green, the event as timer expires, the resulting state as yellow, and the action as changed light to yellow. Let's consider an ATM system where if the user enters an invalid password 3 times, the account will be locked. In this system, if the user enters a valid password in any one of the first 3 attempts, the user will be logged in successfully. If the user enters the invalid password in the first or the second try, the user will be asked to re-enter the password. And finally, if the user enters incorrect password 3 times, the account will be locked. Let's see how this might be represented using a state transition table. In the table, when the user enters the correct PIN, the state is transitioned to S5, which is access granted. And if the user enters a wrong password, they are moved to the next state. If they do enter an incorrect password for a 3rd time, they will then reach a transition to the account locked state. The state transition diagram or the table can be used to derive the necessary test cases. So test the system by entering the correct password on the first attempt, and this should immediately transition the system to the access granted state. You want to test the system by entering an incorrect password on the first attempt and the correct password on the second attempt, and the system should transition from the initial state to the second attempt state, and then to the access granted state. You want to test the system by entering incorrect passwords on the first and the second attempts, and the correct password on the third attempt. And the system should then transition through the first and second attempt states before moving to the access granted state. You want to test the system by entering incorrect passwords on all 3 attempts, and the system should transition through each attempt state and then finally reach the account blocked state. And these test cases cover the critical paths through the state transition system, ensuring that the system handles both correct and incorrect inputs appropriately.